So in the first video for the relationship between two categorical variables, we did really get through all of the new aspects of it. All we have left to do is a second example. At the end of the last video, I did ask you to try to work the problem first because I already provided the StatCrunch output at the very end, so you can at least kind of try to see if it had the output in front of you like you would for a test, if you would feel comfortable in doing the material. We'll go ahead and work through this together. Hopefully you already have your answers so that you can compare as we go. So here we're looking at the Big Brothers Big Sisters program, and they want to see if their program has an impact on the highest college degree someone receives from children of single parents. So we have 120 children of single parents who did participate in the Big Brothers Big Sisters program and 360 that did not. And they recorded their highest college degree. So here's our quick summary of the numbers. Now, see, one thing I did not include here for you were totals. I'm actually going to go ahead and add my totals here for me. So we had 120 participants in the Big Brothers Big Sisters, 360 that were not, for a total of 480 children. Go ahead and get my totals in here as well, so we don't really need them. Go ahead and get them anyway. And 30. Alright, so if we want to get the row percentages, we first need to calculate them. They are actually part of your output, but let's make sure we would know how to get them. So when I get my row percentages, I'm going to kind of quickly redraw my table. So I have none, 2 year, 4 year, and a graduate degree. Yes, no here. And let me go ahead and add the total, because the total should be 100%. And this is a reminder of how to get these numbers. So when I'm looking at the Big Brothers Big Sisters row, for my total, I'm always going to be using the 150 for the 120 here. So to get my number that's going to go here, I'm going to take my 18 out of the 120, which gives me 0.15, which will give me 15% there. To get this number, we're going to take the 27 out of the 120. Got 0.225. 22.5%, and hopefully you could finish that pattern here. So you get 50% for the 4 year and 12.5% for the graduate degree, and then of course you could quickly add those numbers to make sure that they do add up right. In a similar manner, we can get the no row. Just now going to use the 360 as our total. For example, that one will be 18 out of 360. Give me 5%, but then similar ideas there. Get 19.17% there, 35.83% there, 40% there, and then the 5%. So there's at least calculating them, which we could then verify here with our output from StatCrunch. So that second number is the row percent, so I could check to make sure I got the right numbers. Now to discuss the meaning, or in a sense here to interpret these numbers. Just simply interpreting each row. So I start with how many children we have, because we still want to know how many is in each group to represent each 100% that we're looking at. So our 120 children of single parents who did participate in our Big Brothers Big Sisters program, 15% had no college degree, 22.5% had a 2-year degree, 50% had a 4-year degree, and 12.5% had a graduate degree. And then a very similar interpretation there for the second row where they did not participate in Big Brothers Big Sisters. Right, so again, now looking at these numbers, we might want to see, well, is there that relationship between participating in the program and what college degree that people receive? So does there seem to be any discrepancy between these numbers? A little bit, especially once you get to these higher level degrees here. So that's where the hypothesis test is going to help us make that decision. So that's what we're being asked to do next. Does the Big Brothers Big Sisters program significantly affect the highest college degree earned? Use a 2% significance level, so our alpha there is going to be 0.02. Let me first show you how I got the StatCrunch output, because with this way I'm going to be following the summary option instead. So in our StatCrunch directions from last time, there's an option with the summary. For that way, you're going to need to enter your contingency table without the totals, but including the row and column names. So that's what we're going to start with, is just by entering our table. And by our table, I mean the numbers that we started with here. We're not going to include the totals, so just this little box that we already see here. So we're just going to bring up StatCrunch. I'm just going to open StatCrunch when I get here. I'm not going to load a data file this time. And my little participations. This is my Big Brothers Big Sisters, or no. Those with no college degree, a 2-year degree, a 4-year degree, or a graduate degree. And then I'm just going to enter my numbers. So we got our numbers there. Then let's follow the next part of the directions. So we're going to go to Stat, Tables, Contingency with Summary this time. So Stat, Tables, Contingency with Summary. Then we got to select which columns we want to compare. So we want to clear all the ones that have the numbers in it. My row labels are in this column. And then just same options as the other ones. I can also get my row percentages if I want, my expected counts for my checking conditions that I may need, and then possibly those contributions to chi-squared. I left those off in your output this time. So I hit compute. Here's the output that we get. And again, the first part here, the cell format, tells you when you look at an individual cell what each number is. So the first one, again, is the observed count, the row percent in parentheses, then the expected count right below it, and then the contributions to chi-square. And then down here is my test statistic and my p-value that I'm going to need. So we have all the information to be able to do our hypothesis test. So same 5 steps for a hypothesis test, they just look a little bit different. So our first step are the hypotheses. So our null hypothesis will have the idea of them being independent of each other here. The response variable is my column variable, so we're looking at the degree for that one. So I'm going to say that my highest college degree earned by children of single parents is independent of the big brothers, big sisters participation. And then the alternative is the same idea except for that they're dependent. So highest college degree earned by children of single parents is dependent on the big brothers, big sisters participation. So again, the only difference is independent versus dependent. Or in a sense, again, the alternative is that there is a relationship between them. Step 2 is that same decision rule. It did not get impacted here at all. So we're going to reject the null and believe the alternative. If our p-value is less than alpha, and our alpha is at 2% significance level given to us in the problem there. Step 3 starts with our conditions. So here we technically took a stratified sample because we took 120 that did participate and then 360 that did not. So we took some from each of our two groups there. From what was given to us, there was no known bias. We didn't only look at the best people who participated or anything like that. Then we need all of our expected counts to be at least 5. So our expected counts in my output here are just those last numbers. I'm just going to list them. And those are all at least 5. So we're good there. Then we need our test statistic, which again is just going to come from the output. So this 15.266 down here is the test statistic. I still want you to list it. You won't necessarily have to calculate it, but still please at least list it. So our chi-squared is 15.27, and you can just label that in words for yourself. You don't have to write the symbol for me. Then we need our p-value, which again is just kind of come from the StatCrunch output. So it's 0.0016. Again, you'll never have to calculate that. It'll be given to you there in StatCrunch. Going back to step 2, that is less than our significance level of 0.02. So we are going to reject the null and believe the alternative. Then finally in step 5, same format, so we start with our alpha. Since we did reject, there is statistically significant evidence. To support. And then the last thing was our alternative hypothesis, but in words. Notice it already is. So there is evidence to support that highest college degree earned by children of single parents is dependent on big brothers, big sisters participation. Now please note with the way this interpretation is phrased, we just know that there's a relationship between them, but we don't know how. There could actually be a relationship, and those with the big brothers, big sisters are less likely to get a college degree. So as I said, it actually does not give us the direction which is why then being able to go back and look at the percentages is very helpful. That way we can sort of see where those relationships do actually occur. Alright, some last follow-up questions. That still idea of hypothesis testing still carries on here. So which type of error could we have committed? Well, remember, a type 1 error is when we reject the null, but the null is actually true. A type 2 error is when we do not reject the null, but the null is really false. So what decision did we make? Well, we rejected the null. So if we reject the null, the only error we could have made is the type 1 then. Some possible consequences there. Maybe we continue a bad program, which of course would cost time and money. So we think it's helping when it really isn't. If we think it's making things worse when it really isn't, get rid of an okay program, which probably wouldn't be as big of a deal. It's not really helping that much there. What could we do to reduce the chance of this error? So there's two different ways to make that smaller. So remember, the chance of a type 1 error is that significance level we set. So how can we make alpha smaller? Remember, alpha is the probability of a type 1 error. So the two things that we can do, we can increase our sample size. The more data we collect, the less chance that we make an error. Or we can set a smaller alpha for the problem. Alright, so that's everything new. A little bit of review there as well. Another example. Got to see StatCrunch with the summary way of doing it as well. Remember, if you have questions, don't hesitate to email me.